Hello, you guys. How are you all? So this is the review for the Chapter 10 quiz. I believe it goes from 10.1 to 10.4 or 10.6, one of those two. So in going through there, we're going to just quickly review everything that was in those units and then also give you some additional resources if you need help. And then also, once you're finished with this, you should be able to go through and complete the chapter review. That's at the end of the unit and be all set and ready for the quiz that's coming up. So as we go through here, first off, you'll remember in this unit we had talked a lot about scatter plots. Scatter plots, remember, show the relationship between two sets of data. Oops, let me go back. And then, as always, you can read ordered pairs off of a scatter plot. So for example, we can go through and look at the x and the y coordinates on those and get the coordinates for both. Then we can also write those as the x or the left and right axis over the y or the up and down. So sometimes I like to write that as the left to right and then up and down. Remember that when you're looking at scatter plots, you must have two sets of data, and that means that they are both quantities. So we're looking for two sets of numbers that can be compared on your scatter plots. An example that I give you on this one, that's my little cursor, is that you could use the age in years versus the value of vehicles, because age is a number and value in dollars is also a number. But you could not use the color of the car versus the value of the car, because that color, red, green, blue, whatever color it is not a quantitative value. It's not something that we can count and plot. So remember, when we were analyzing our scatter plots, we looked for two different pieces. One was we talked about clustering, and this is where groups of data tend to fall together on the scatter plot. And then we also looked at the concept of an outlier. Remember, we can see a cluster here. This is blood glucose lab results. So here's this. And then out here we see that this point just doesn't seem to fit in with the rest of them, and that is considered an outlier. Remember, sometimes for data we're looking for outliers, and then other times we're looking more at the cluster, so we'll just throw the outliers out as data points. Next, there can be different types of linear associations with scatter plots. You could have a positive association. You can see this trend increases as one increases the other. So as the y-axis, or excuse me, as the x-axis goes up, the y-axis does the same. There can also be a negative correlation between the two, or negative association. As we go positive on the x-axis, we can see that the y-axis value drops. Then lastly, we sometimes see that there's no association between the points of data. They tend to just be a scattered mess, if you will, and we don't see a clear pattern between them. So next, we're looking at modeling with data, and probably the most useful thing that you'll learn how to do is to create what's called a trend line, or sometimes we also call it a line of best fit. When you're drawing a line of best fit, your task is to go through as many points as possible, and then also to balance the number of points both above and below the line. So I'll go ahead and pause for a second. I'll show you how to do a line of best fit. So you guys can see here I have my graph the same as we saw over there, and I apologize for the skew of it. You can see that I have miles per gallon on the y-axis, and then I have the weight of the car in thousands of pounds along the x-axis. And we can see really clearly that there's a data trend here that is a negative association between the miles per gallon and the weight of the car, meaning that as the weight of the car increases, the miles per gallon decreases. So in order to find the line of best fit, I need a marker and a ruler. So what I'm going to do is start playing with placement on my ruler to look to see where can I put this line to go through as many points as possible, but to still keep the same number of points above and below the line. So what I like to do is go through and kind of count here. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 under, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You can kind of see I only have 10 below. So that means I need to adjust my ruler to get more points below the line as above. So I'll count again now. It's going through these points, but I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 on one side, and it'll go through those. So about 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 below. So this looks like a pretty good place to place my line of best fit. So I'm going to go ahead and roll my ruler flat, grab my Sharpie marker, and then I'm just going to draw that line in. Now there's of course much more accurate ways of finding your line of best fit. Probably the best way to do it is using either a graphing program like Excel, or to also use the graphing calculators, the TIs, that are in Miss P's room. So you guys can see now that we went through on ours and added the line of best fit, which is the same as they've done here. Remember again, you want to balance those points both above and below the trend line. Now next is finding the equation of the trend line. So when we're looking at our line of best fit, the equation for that line becomes very important. So for this, we're going to use our standard y equals mx plus b equation. So y equals m, which is the slope of the line, times the x value, plus b, which is the y-intercept, or where the point or line crosses the y-axis. So in doing that, you kind of have a three-step process. First, you're going to find the slope of the line, which is m. And to do that, you locate any 2 points that are on the line of best fit. So I could use this value here, which looks like 75 and 1. And I could use another one that is on the line, which maybe this one is there. So that looks about at maybe 67, 68, and 3. And then I would subtract my 2 x values. So I would subtract from 75 to 68. And then I would also subtract my x values, which would go from 1 to 3. So that would be 2. I would plug those in here, and I would get a value for my slope. I'll show you an exact example in just a minute. Then I'm also going to want to find the y-intercept, which is where this trend line crosses the y-axis. So in order to do that, I can look just on my graph, and I can see that it's crossing just under 80. So I could safely use 80 as my b value. If for some reason you can't read it clearly on the graph, or if you happen to have a table of values, you should also remember that the y-intercept is wherever x equals 0. So it's wherever that x value is 0. Now, once I've found my m and I found my b, I literally rewrite this equation, replacing m with the value I calculated and b with the value I calculated here. Okay, let's go ahead and try an example of that one. So when I'm calculating my equation for my line, I'm going to go ahead and use, like I said, that formula y equals mx plus b. And in doing so, I'm going to remind you guys that I'm looking to fill in the m and the b. So the first place I want to start is with the m, which is the slope. So I want to find 2 places on the graph where I could easily calculate their values, 2 points that are on the line. If you see those 2 that I marked right here, those are both sitting right on the line. So on this point, you can see that my value looks like it's maybe right about at, probably at about 1/2. So I'm going to call that 0.5. You noticed I was about halfway, or excuse me, this is 2, so that would actually be 1, because I'm sitting at about halfway between 0 and 2. So this point here would be 1 on the x, and then our value for y is looking probably at about being 31. And since I'm reading those off the graph, I'm going to make an estimation. Then on this value down here, I'm looking part between 3 and 4, so that's about 3.5. And then my other value is here. I'm going to follow it over. It's looking like between 15 and 20, but closer to 20, so let's call that 18. And those become my 2 points that I'm going to use to calculate the slope. So I gave you that formula, slope equals the second y minus the first y over the second x minus the first x. So I can plug that in. My second y is right here. So I'm going to have 18 minus 31 over 3.5 minus 1. So I'm going to go ahead from 18 to 31. I'm going to drop how many points? I'll wait while you get your calculator out. Go ahead and check. It's from 31 down to 18. So if you've done your math correctly, that should tell us that that drops about 13. And then this one from 3.5 down to 1, it's going to go, the difference there is about 2.5. So 13 over 2.5 becomes my slope. And remember we said we're going to write that in that formula, y equals mx plus b. So you can see that up there. So the m I'm going to replace with that, negative 13 over 2.5 x. Now I just need to find my b value, which is this one right here, which like we said is where the line crosses the y-axis. So we come right up, we're sitting right about here. So if we figure this is 30, this is 35, that's looking probably at about 32. So the equation for this line of best fit is going to be y equals negative 13 over 2.5, and I can actually do that math on that one if you'd like and divide it out. So that would be negative 5.2. X plus 32. So that gives us the equation of that line. So since we can calculate now the equation of the trend line, I'm going to tell you explicitly that that's a very important thing to know how to do. So if you don't know how to do it, I'm going to suggest that you can also go online to this website, which is learnzillion.com, to this lesson plan, and they will show you another example of how to write an equation for a line of best fit. If you have any questions at all about doing it, I promise that you should go online and look, because it's going to show up on your quiz. There is, of course, though, aside from that long-handed way, a shorter way to do it. So you can also use your graphing calculator to find your trend line or your line of best fit. And in order to do that, there's a 4-minute video that's on YouTube right here that will walk you through on exactly the same calculators as we have in class. So take your time and go and watch that one also. Lastly, on this sheet, you want to talk about two-way tables. Two-way tables are just a way of showing two different pieces of information and letting us calculate the frequency that each of those categories happens. When we're analyzing two-way tables, we want to look for trends between the rows and the columns, or also between the titles and the totals. So when we look at this, we can see that proportionally, there's proportionally a higher number of women or females who own sport utility vehicles than there are men. We can also see that when it comes to sports cars, that it appears that out of our 84 owners, the majority of the sports cars are owned by women instead of men, which is a little different than you might have expected. When you're looking to calculate your relative frequency, you want to find the ratio of the row against the total or the column, or whichever it is that you're comparing. So for example, if I'm looking for the relative frequency of males who own sports cars, so I'm looking for this column right here, what I'm going to do is take the male row, so I'm going to compare those who own sports cars, which is 39, out of the total. And that gives me a frequency of 39 out of 60. I can divide that down to a fraction or to a decimal, and I'll get 0.65. Okay, if you have questions about two-way tables, please make sure you stop and ask. There's lots of examples in your textbook also. Okay, to wrap it all up, before you start on your test for later, I'm going to go ahead and give you my famous little math joke. This one's a chart that shows you what you might see if you looked at a mountain range through a tennis racket. Hopefully your test will make a lot more sense than that. If you have questions, let me know and make sure you practice well.